In the last video, we talked about position time graphs. In this video, we're going to talk about velocity time graphs. And it can get a little confusing because you're looking for a lot of the same things. The graphs look similar, but we have to read them in a completely different way because this time we're reading velocity instead of position. And in this case, if I look at from A to B, okay, from A to B, I start with a velocity of +4, and I end at B with a velocity of 0. Okay, that means I'm changing speed. Before, a straight line meant constant speed, but in this case, a tilted line means changing speed. And then a flat line, like from C to D, at C I start with a speed of -2, I end with a speed of -2. Everywhere along in there I have a speed of -2. So a flat line means a constant speed. So in the other graphs, a flat line meant at rest and a straight line meant constant speed. In a velocity graph, a flat line means constant speed and a straight tilted line means changing speed. You won't ever really see curved lines on this type of graph. Now, if I'm below the axis, like from B to C, the velocities are negative, C to D. So if I'm below the axis, I have a negative velocity and a negative velocity means that it is going backward. So before, if it was tilting down, it was going backward, but in a velocity time graph, if it's below the axis, it's going backward. If it's tilting toward the x-axis, like it is from A to B, I'm going toward the x-axis. The x-axis is 0 velocity. That's stopped, okay, right here. So if I'm tilting toward the axis, I'm getting towards 0. That means my velocity is decreasing, or I'm slowing down, okay? Look at BC. It's a little surprising, but when I go from B, the velocity is 0. C, the velocity is -2, but -2 just means backward 2. So I started with a velocity of 0, and at the end, at C, I'm going at a velocity of 2, so I'm speeding up. So even though the line is tilting down, because it's going away from the axis, that means I'm actually speeding up. Slope is change in y over change in x, but on our y-axis we have velocity, and on our x-axis we have time, so change y over change in x becomes change in v over change in t. We should recognize that. Change in velocity over change in time is acceleration. And then the last part is not obvious, but the area between the line and the x-axis is the displacement. And I'll show you how that works in our examples. Okay, now we're going to actually figure this out for the graph above. We're going to split it into 3 sections, A to B, then B to C, and then C to D. All right, so we're going to start with A to B. From A to B, let's describe the motion first. So it's above the axis, positive velocities. That means it's going forward. So we'll write that as going forward. And we know that because it is above the axis. Okay. Second thing about it, constant speed, speeding up or slowing down. It's changing speed because it's a tilted line, and it turns out it's slowing down because it's approaching 0, okay, approaching the x-axis. So we're going to say it's slowing down. Okay, it's approaching the x-axis. Now we can find the acceleration. Acceleration is change in velocity over change in time. I'm basically just finding the slope. So for that one, we start with a velocity of 4 and end at 0. So we would do like y2 minus y1 would give me 0 minus 4 meters per second over time. For that is 6 seconds from 0 to 6. So 6 minus 0. And that's going to give me minus 0.66 repeating, and my units end up meters per second is meters per second squared. And then our displacement. We set up above here is the area between the line and the axis. So here's the x-axis, here's my line. It's this area here, so it's a triangle. How do we find the area of a triangle? We do base times height divided by 2. The base of it is 6 because it goes from 0 to 6. And the height of it is 4. So it's going to be 6 seconds is the base. I'm going to keep the units just so you see what happens. The height of it is 4 meters per second divided by 2. And that's going to be 24 divided by 2 is 12. I have meters per second times seconds. The seconds are going to cancel, and I'm left with meters, which makes sense for a displacement. So for that section, the displacement is 12 meters. Now we're going to do from B to C. Okay, from B to C, first question we have to ask, is it going forward or backward? It's below the axis. Negative velocities means it's going backward. So we're going to write that it is backward. Because it is below the axis. All right, speeding up or slowing down. And again, this might be a little surprising, but I'm starting with a velocity of 0. I'm ending with a velocity of 2 backward. That's speeding up. It's at rest right here. It's moving at point C, so it has to be speeding up. So we're going to write that it is speeding up. Because it's going away from the x-axis. And then we can find the acceleration is change in velocity over change in time. All right, so our velocities, we start at 0 and end at -2, so it would be -2 minus 0. Divided by, and then our time goes from 6 to 9, so 9 minus 6. And that's going to give us -0.66, repeating again, meters per second squared. Now, it has the same acceleration we had for AB, and if you think about it, it's a straight line from A to B to C. The slope doesn't change. If slope is acceleration, those two accelerations have to be the same because the slope is the same all the way through there. And then one last thing, we're going to find the displacement. So delta x equals area. Again, it's between the x-axis and my line. So here's my x-axis, here's my line. So again, it's a triangle, like so. So we have to find the area of that triangle. We're going to do base times height divided by 2 again. Now the base of it is 3 seconds. Because it went from 6 to 9 in the time, if you remember. The height of it is going to be -2 meters per second. -2 because it's below the axis, divided by 2, and that gives me -6 meters. Oh, I'm sorry, -3. -3 meters for the displacement. Now, I want to try to put this all together and see if it makes sense. All right? We said it's going backward up here. We ended up with a negative displacement there. That makes sense. For AB, we said it's going forward right here, and it has a positive displacement. That makes sense. The acceleration here is negative, and it's slowing down. And we've almost always said that negative acceleration means slowing down. So that makes sense. This is the one that might be a little confusing. Over here, we have a negative acceleration, and we're speeding up. How can that be? Here's the reason. The negative just means direction. Okay, in AB, I'm moving forward. Negative acceleration, the acceleration is backward. So it's moving forward, but something's pushing back on it. That's going to make it slow down. In BC, I'm moving backward, and the negative acceleration is backward. So it's moving backward and being pushed backward, and that's going to make it speed up. So a negative acceleration will make you speed up if you're going backward. A negative acceleration will make you slow down if you're going forward. And then for CD, let's take a look at that. what's happening. Are we going backward or forward? Now, you might be tempted to say, oh, it's a flat line, so we're at rest. But remember, this is a velocity time graph. They're a little bit different. I'm below the axis. It has a negative velocity. Therefore, it's going backward. So we'll make a note that it's going backward. And we know that because it is below the axis. Okay? It's a constant speed. Because it's a flat line. Okay? If you look at it, okay, C it's -2, D it's -2, -2 all the way across there. That is a constant speed of -2. The acceleration is change in v over change in t. Well, that's going to be 0 because the velocity stays the same. And that's what constant speed means no acceleration. So those things match. And then my displacement is the area, again, between the line and the x-axis. If I look at my line, here's my line, here's the x-axis, it's this area. Okay, so it's a rectangle this time. Area of a rectangle is just base times height. So it equals base times height. The base of this thing is, from 9 to 14 is 5 seconds. So 5 seconds. And the height of it is -2 meters per second. And that's going to give you a displacement of -10 meters. So again, we're going to have to know these rules and actually be able to go back and forth between position time graphs, which we studied in the last video, and velocity time graphs, which we studied in this video.